All right. Thank you once again. Thank you for the opportunity that has been given to me. Good evening to everyone. My name is Abudimana Suzanne Christine, and I'm here today to present my paper on the characterization of excavated municipal solid waste in view of landfill mining. Supervised by Dr. Fozia and Professor Agamutu. So the content of my work is as it is here: introduction, experimental setup, results, and conclusion. So in the last year, it has been found out that the generation of municipal waste have increased and they is supposed to rise to 2.2 billion tons in 2025. And Asia alone account for 70 million of tons of municipal waste. And the generation of this waste account to 26% in Southeast Asia. Here, as we can see, the kilogram per capita per day only in Malaysia have increased from 1.1 kg to 1.2 kgs. And because of the expansion of the population, there is demand for land because the waste is increasing gradually. And among the 146 operating landfill, only 18 here are sanitary landfill. So more than 50% of the other landfill are still open dump. So here come landfill mining as an opportunity to obtain mineral or other solid resources from the material waste that have been excavated. So this method have been used before for the first time in Tel Aviv in 1953 for purpose of remediation, but also to recover the landfill space. Is it really a solution for Malaysia case? Our study will help us to define and answer that question. But potentially here, there is still not a great role in the segregation of the waste. So most of the waste, municipal waste, end up in the landfill because of the separation at the collection is mostly inexistent, if not rare. So landfill mining as a sustainable approach can help us to recover energy or material. And in our study, the main objective is to reduce the landfill space to be able to recover that space for a recreational park for the landfill to be converted to a recreational park. So the material that will be harvested will be converted for energy or engineering application. Our methodology: the waste was excavated from the landfill waste. The waste was collected in Jeram Sanitary Landfill here in Malaysia. And after collection, the waste undergone through characterization. From the characterization, the opportunity of waste to energy was explored. So we use XRD. We use XRD in order to determine the material in which the energy potential can be found. We also use particle size distribution because we wanted to determine the fraction where the flow of the desired material is mostly found also. And then later on, we proceed to the calorific analysis to determine the eating value. So some of the questions that we have asked is, what are the different type of material excavated? Do waste material characterization really influence the landfill mining? And is it possible to implement the landfill mining for a profitable recovery in this case? So our experimental plan and analysis is the step 1, excavation, step 2, characterization, and step 3, valorization option. So the material was, after excavation, it was dried, then sieved, separated in different fractions, plastic, metal, textile, wood, paper, cardboard, glass, and ceramics, and then characterize through the different analyses that I previously cited. And then we explore the valorization option. So the results show us that among the waste that was excavated, that predominantly we have mostly plastics and fine material. That fine material, also called soil-like material, is mostly the organic fraction. Based on the physical chemical analysis, the moisture content was also very high. So here you can see the alkaline state confirmed the methanogenesis stage of the landfill, which means the organic material is still remaining in the landfill. To say that the landfill cell that we have excavated is 5 years, so there's a great potential for that organic material still remaining in the excavated cell. And from the plastic, we have also found out that the plastic is predominant, so account to 36% of the waste composition on a dry basis, compared to the fine material that was 34% of the waste material. The combination of the two materials was also studied to know the potential for recovery, and they were also studied separately. The mineralogical characterization, as I said before, it helps us to determine in which material the energy potential can be found. However, this is a preliminary study to know which minerals and what is found in the different excavated material. So from the two finest particles here, they display consistent difference. So we can already say that there is no possible enrichment from material from the first bit that was SD2 and material from the third bit that was SD3. However, most of the material fall in the category of less than 25 millimeter. And we found out also that there is a great amount of chlorine and that was found in the pit and in XRD. Also, the mineralogical analysis show us that the sample that undergone through XRD display the presence or occurrence of gypsum. That gypsum is must be originating from the construction and demolition waste that has been deposited in the landfill. And one of the suitable treatment for this material that was found there, for the fine material, will be the pyrolysis due to the chlorine and sulfate content that was found in the material. So the leachate characterization helps us to define which treatment can be done to the waste, because after excavation, we found out that there is a discharge of contaminants of new nature, which are methylene chloride, phenol 1,4-methyl, and hexadecanoic acyl ethyl ester. These contaminants are mostly because of the heterogeneity of the waste and the degradation of the plastic that have been piled in the landfill. So they are still occurring because of this heterogeneity. So mostly study needs to be done to know how the material and their occurrence affect the landfill mining. The valorization option for the one opportunity could be in the combustible fraction, which is a plastic. And we have found out that the plastic has a potential to be recovered that is higher compared to the fine material. Based on the ultimate analysis, we found out that most of those material, plastic and fine material, are mostly bound to organic material in the waste. So the fine material can also be valorized as a fertilizer or compost depending on the quality of the material that still need to be studied. The geochemical analysis need to still be done to define if the material is potentially viable for the study, for the landfill mining study. So the eating value, after separating the waste, the different material were undergone through the eating value, calorific value, and we have found out that plastic also have a high potential of energy recovery compared to fine material. The energy potential show a eating value of 166,897 kilocalorie per kilogram of the excavated waste, and the total recovered energy for that cell could be estimated to 478,352.25 kilocal per kilogram. So there is a great potential for plastic actually, and fine material or soil-like material to be recovered from the landfill in order to process to landfill mining. So in conclusion, we have found out that plastic and fine can be used for energy recovery. Their economic values still need to be explored, and further treatment for fractionation of those wastes, and we need to be done to optimize the energy recovery, and the quality of the excavated material still need to be investigated. So I want to thank you for your attention. Thank you once again for the time given to me to present my preliminary work. Thank you.
Thank you, Suzanne. There is any question for Suzanne? I have one, if I can. Have you done a sort of economic assessment of this process, of the whole process of excavation materials recovery, and then the recovery of also of the sites?
Okay, thank you for your question. Actually, we have not yet done the economic value assessment, because we are not done with the geochemical analysis of the waste, because we still need to put that data into the economical assessment. So I believe that will be after we get those data done.
Okay, thank you very much. Then we can move to the next presentation. Thank you, Suzanne, again.
Okay, thank you.
Juliana, the floor is yours.
Yes. So now we would like to invite Laura to speak about the circular economy in the construction sector with the European framework and the NEA activities. Please, Laura.
Yes, the presentation will be done by my colleague, Paola Altamura.
Sorry,
I didn't, sorry.
Paola.
Paola Altamura,
no
problem.
researcher at NEA. Okay, thank you, Paola.
Please,
thank you, Juliana.
Thank you.
Thank you.
Can you see the slides? I hope so.
Yes.
Okay. So good afternoon, everybody. I'm Paola Altamura, and I'm a fellow researcher at ENEA, the Italian National Agency for New Technologies, Energy and Sustainable Economic Development. At our laboratory, which is led by Laura Cutaia, we are working on circular economy in different sectors, and I'm presenting you today all the activities that we are conducting, in particular within the construction sector, with reference to the European framework. So we are actually in a very peculiar moment for the construction sector, because policies such as the renovation wave, for example, are really moving the sector. And for example, in our country, in Italy, the level of activity of the sector after the pandemic in this recovery phase that we are starting now is really raising high, thanks to policies which rely on the renovation wave, and all the all the fiscal policies that are helping the sector to start need to be complemented with the policies that are regarding circularity in order to be able to provide a fully circular and sustainable result. So Enea is working on the field of construction and demolition waste valorization in many projects, many financed projects, such as the Condoref project that will be presented by a colleague during the session. We've been developing a project which is called Decorum, and I will present it to you. And we're working also on a large project for public administrations in Italy to provide them tools regarding energy and sustainability in general, and more specifically also for building and construction and management. And I will also give you an insight about the Stockpiles project, in which Enea is one of the partners, and that will be presented again today by our colleagues Francesco Tinti after. So Enea is also working on a set of activities which are not financed, which we do voluntarily, and but are very important for us in order to promote circular economy in our country, and more in general to collaborate with other stakeholders in Italy and in Europe. In particular, we are a part of the European Circular Economy Stakeholder Platform, Hbss, the Hbss, and in particular, I will show you the activities that we are conducting within the leadership group Construction and Infrastructure, and also Enea is leading the mirror platform of Hbss in Italy, which is the Hbss platform. So I will show you what we are doing there, and we've been collaborating very closely with the Green Building Council Italy, who is the association that's developed the lead protocol for our country, for Italy. And we've been collaborating to the definition of guidelines for the design of circular buildings for Italy. And these are based on the EU Commission paper published in 2020, Circular Economy Principles for Building Design. So this is a public document that you surely might know. Within the Hbss platform that I mentioned, in particular, I'd like to show you some activities that we have done in this network of networks that Hbss represents. Hbss is very useful because it's promoted by the European Commission and European Economic and Social Committee, and it engages the most relevant stakeholders across Europe in the different sectors, also in the construction sectors, but there are leadership groups for many different sectors. So it's a very rich platform that has also a wide number of good practices that you can see here in the website. In 2020, with the leadership group on construction, we've been publishing an orientation paper, which is public and available for everyone to be downloaded, where the leadership group construction defined 6 priority areas of intervention to promote circularity in the construction sector. Just to give you an idea of what we've been working with together with other relevant stakeholders in Europe. We've been identifying, for example, that integrated policies and governance, as well as metrics for circularity in the construction sector are needed, but also integrated tools to foster interconnections among the construction sector and other productive sectors that could have some exchanges in terms of flows of materials that could be used within the construction sector. Other areas regard the need to promote territorial initiatives to close the loop within the value chain. And then another area regards educational initiatives and citizens awareness raising initiatives. So we've been looking at all the actions that should be promoted in all these 6 areas. This year, in the new leadership group, in which Laura Cotaya is working, and we are collaborating as ENEA, we've been organizing an event that is next week. So we are kindly inviting you to follow it, because it's all focused on circularity within the construction and infrastructure value chain. And this is an EU circular talk, a format that the Hbss platform has developed and is promoting in order to stimulate the debate between the stakeholders and the Commission. So there will be many speakers also from the Commission in a dialogue with the main stakeholders of the sector in Europe. And the event is accessible upon registration. Here you will find the link. And the event is organized in 2 sessions. The first one is on the 28th September, and will focus on the potential of circularity of the construction and infrastructure value chains, and on the actual and potential relation between these value chains and other value chains where secondary materials could be exchanged in order to substitute primary materials. So we've been doing a study on this potential rate of substitution in Italy for many sectors, many let's say many value chains within the construction value chains, and you can see here the results. And but there we know that there is a large potential which is not being used for now. So there are so many secondary materials that could enter the production cycle in the construction sector that are still need to be exploited in a better way. So the second aspect that we will investigate in the second session on the 30th of September will be the aspect of the market of primary and secondary materials. So we've been identifying the main stakeholders in the market, and we are looking at present barriers and potential levers to increase circularity in the sector. In particular, we're looking at how the competitiveness of recycled materials is affected today in the construction sector by technological and logistic aspects, but also legislative aspects in many countries, in Italy as well. And we've been looking at the acceptance of these materials as a barrier. But looking at the policies, we've been finding many levers that have been developed in different countries, from, for example, mandatory green public procurement in the construction sector, as we have it in Italy, but also other fiscal policies like the ones that, for example, France has introduced in their national roadmap to circular economy. So there are many aspects that could be interesting to follow up during the event. As regards our activities within the Mirror platform in Italy, Hbss, we've been collecting good practices from across Italy. So we have more than 160 good practices that show the Italian way for circular economy in a way. And we've been working and collaborating with many stakeholders across the country. In particular, there is a working group within Hbss, which is all focused on sustainable and circular design, production, distribution, and consumption systems and models. And within the working group, we have a subgroup dedicated to construction and demolition waste. The subgroup has been publishing a position paper released in 2020, and it's public and available. And this document developed by all the stakeholders in the subgroup that you see here on the left side, and that really comprehends many different types of stakeholders, from research centers to university to associations of companies of different types, has defined the priorities practice for the sector in Italy for construction and demolition waste circular management. In particular, we've been looking at how the legislative framework in Italy is creating some barriers to the development of a higher level of circularity in our country. But we also have, as I mentioned, some levers as the mandatory GPP, which can help us. So in this sense, we are working within many different research projects, collaborating with different partners from many countries. We should have a presentation on CONTREF today, so you will have insights on this very large project which is an Interreg project, which involves 7 different countries that are exchanging good practices in order to boost the circularity in the construction sector in the relative countries. And now we've also concluded a 2 years project financed again with European funds, but all focused on Italy in this case, which is the Decorum project that we've developed with Contento Trade and Softlab, 2 Italian companies. This project led to the creation of a platform in support of all actors within the construction supply chain, to help them in the decision-making phases, and in order to facilitate the inclusion, the adoption of secondary materials for the construction sector, and in order to promote the compliance of works with sustainability criteria, and in particular with our national minimum environmental criteria for green public procurement, which are mandatory. And this platform also has a marketplace that promotes the availability and the reliability and the accessibility to the secondary materials for constructions. Within the ESPA project, Enea is working, as I said before, on many different tools to transfer all these innovative approaches, circular approaches, to public administrations. And in particular, we've been working on 3 tasks, 3 different activities, one concerning environmental certifications for public buildings. So we've been developing guidelines for public administration to adopt these rating systems for buildings. And then we've been developing 2 specific activities on circular economy for the construction sector, one regarding the preparation of guidelines to estimate the quantities and the typologies of materials that can be recovered from existing buildings, so in a urban mining approach. And the last activity regards a report that has been already published and is available upon registration at this link that you see, that you can find in the slides. A report that collects and systematizes different methodologies and technologies available to recover components and materials from existing buildings. So this report looks at selective demolition and different technologies to recover and make components available for reuse or materials available for recycling. Finally, one last project that will be presented by our colleague Francesco Tinti later this afternoon is the Stockpiles project, which is financed by the EIT within the KIC raw material, and it's a project that looks at the possibility to recover critical raw materials from mining activities residuals, so from what are called stockpiles and tailings. And in particular, as from Enea, within this project, are looking at how these circular processes might represent a real occasion for sustainable economic development. And we are assessing the environmental impacts that can be avoided thanks to the recovery of the critical raw materials from these residues instead of mining them from primary sources. So these projects will be described later in more detail. Thank you very much. I'm here for any question.
Paula, thank you very much for your exposure. And I would like to ask to everyone if do you have any question for Paula? Anyone? No doubts, people.
There also might be some questions in the chat and then discussed during the discussion session. So maybe it will come.
Juliana, we don't take questions at the end of the speech, just in the discussion panel.
The end. Okay, perfect. So, Peter, please.
Yes. I can go to the next presentation. The next one is waste to fuel. So I suppose it's Marco Botta who will be presenting this. He's working in Any Rewind in the task force for implementation of industrial scale of waste to fuel technology. So Marco, please, the floor is yours.
Thank you very much for introduction. I will share the presentation. I suppose that you can see the screen.
Yes, I can see the screen. It's
okay,
it's full screen.
Full screen, perfect. Okay, good afternoon, everybody. I'm Marco Botta. I work in Any Rewind. Any Rewind is the environmental company of Eni that's mainly focused on 4 kinds of activities related to remediation, water treatment, waste management, and development on new projects. Regarding the remediation, we can highlight that currently we are managing more than 60 operative remediation work sites. About the water, we can highlight that we are managing 42 water treatment plants, while for the waste management, the main data is related to the amount of industrial waste that we ever here manage, that are more than 2 million tons per year. And finally, regarding development, we are speaking about several projects that are in the area of circular economy, like the waste to fuel project, that is the project that I will present today. Before to go in the details of this project, of this technology, I would provide to you some information about the framework, on the context. We are in Italy. In Italy, we apply the municipal sorting waste collection. In 2019, we reached the 61% of sorted waste collection, with more than 18 million tons of waste sorted in this year. Of this amount of waste, the main impacting fraction is represented from the organic waste. That the amount in 2019 to more than 7 million tons of waste. So you can understand we are speaking about then quite the half of entire sorting collection. Another information that we have to consider is related to the perspective, the forecast that we can have, because if you see the map on the right side of this slide, we can see that the sorting collection is not homogeneous around Italy, because in the north of Italy we reach interesting value more than 70%, while in the center of mid and mid of Italy the results are not so good, but there are several projects to improve the sorting collection also in those areas. So we can expect that in the future more additional sorted waste will be collected, and especially organic waste. So the organic waste is one of the most important portion of sorted waste that we have to manage in Italy. Currently, there are 2 technologies that are commonly used to manage this typology of waste, that are the anaerobic digestion, that allows to produce biomethane, and composting, that allows to obtain the compost. The solution proposed by Eni is a third way, is named waste to fuel, and as we can see in the next slides, it allows to produce bio-oil, biomethane, and water. The technology patented by Eni comes from the Research and Development Department of Eni, and it try to emulate what the nature already does, because we know that coming from organisms that are captured in underground, after thousands of years, we can obtain hydrocarbons that can be extracted and transformed in fuels. In a similar way, starting from an organic waste, but applying a technology and where in a very limited timing, because we are speaking about 2-3 hours, through a process of hydrothermal liquefaction, we can obtain a bio-oil that with characteristics really similar to a fossil fuel that can be used in a similar way to produce fuels for automotive, for example. In a waste-to-fuel plant, we have several sections. The first section is represented by a pretreatment that is useful to remove all the components not related to the organic fraction, like, for example, wood, plastics, metals that can be present for errors in the sorted collection. After that, we have a grinding phase and homogenization that allows to obtain an organic waste ready to be sent to a reactor. The reactor is the core of the technology. Here, with temperature between 250 to 350 degrees and with a pressure between 50 and 160 bar, we have the transformation of the organic fraction and we can obtain a solution, a gas liquid solution. We also have some solids that will be filtered. Those solids maintains a high heating value, so can be used to obtain heat to sustain the reaction. Coming back to the solution, gas liquid solution, through a separator, we can remove CO2, and then the liquid part will be separated in bio-oil, that is the product that will be commercialized, and water that will be sent to a water treatment section, where we also can produce biomethane and recover the water that is originally contained in the organic waste. So just to recap, we can say that starting from the organic waste on the left, we can obtain through this process 3 products that are bio-oil, that is the characteristic of this transformation, biomethane, and water. The yield of this transformation will vary depending on the composition of organic waste. In particular, depending on the solid content that we have inside the organic waste, and especially based on the percentage of fatty substances and proteins. In particular, the bio-oil, depending on those characteristics, can vary from a yield of from 3 to 16% on the total waste in input. The other products are the biomethane that can be obtained during the process of water treatment, because we apply also an anaerobic digestion of water, but we are speaking about a very small quantity, around 1% on the total waste in input. And finally, we have the water. The organic waste is mainly composed by water. It can reach also the 80% of the total composition of organic waste. We are able to recover an important portion of this water, up to 60% of what it is originally contained in the waste. Regarding the bio-oil, that is, I remember, is the main characteristic of this process, because it is unique between the others to obtain this typology of product. If we compare the bio-oil on the left with a typical heavy fuel oil, we can see that the characteristics are really similar. Just we observe some differences on the acidity and due to the presence of oxygen and nitrogen in higher quantities. So due to these characteristics, we can use the bioil produced through this transformation or directly as a marine bunker fuel for maritime transportation, but in formulation with traditional fuels because we have to reduce the acidity. Otherwise, we can use this bioil to produce electricity or in refinery processes to obtain traditional biofuels for example, for automotive. What is the status of implementation of the technology? The technology was tested the first time in 2013 through a experimental plant that was built in the Yenai Donegani Research Center in Novara. It was a very small plant, but really important because it was useful to demonstrate that the transformation was effective. Then in 2018, a new plant has been built in Gela. It's a pilot plant. This larger plant that is currently in operation. Thanks to the information collected from this plant, we are also designing the first implementation on industrial scale that we expect to realize in Porto Marghera, that is close to Venice. In the next slide, we can see some additional information about these applications. In particular, regarding the pilot plant in Gela, you can see here a larger picture. This plant has been built in December 18. The capacity is to treat around 700 kilograms per day. We use this plant to organize some long-run tests that allow to collect information about the production in continuous operation to verify the overall process. We can verify the design and collect lessons learned useful for the industrial scale design. We have also started some activities of upgrade of this plant because collecting information about this technology during these 2 years, we were able to define some opportunities of improvement of the technology. So we are also doing some activities of upgrading that we expect will be useful to improve the performance of this technology. As mentioned before, the first implementation on industrial scale is expected in Porto Marghera. Here we expect to build a very large plant able to process around 150,000 kilotons per year of organic waste, able to treat the organic waste collected in the entire Venice area. This plant will be proposed to the Venice municipality with a project financing approach. Eni Rewind will propose the plant to the municipality that will pay a fixed fee for the organic waste management that will cover the construction costs plus a profit. Eni Rewind is also evaluating potential local synergies with other companies because in the area there are some opportunities to make in continuity with companies that have expertise in the managing of, for example, the remaining water that should be treated after the waste process. At the moment, we have finalized the front-end engineering design for this plant. We are also performing some additional activity to try to optimize the capex estimate, and we have started also the permitting process, requesting the authorization to authorities. At the moment, the startup of this plant is expected in 2024. In the last slide, I will try to summarize the main benefit, main characteristics of the waste-to-fuel technology. That is, I remember, a ENI patented technology. We have 7 patents to protect the different aspects of this technology. The first element that I want to highlight is the production of a bio-oil that is quite similar an heavy fuel oil, but with a very low sulfur content. So it's a very interesting product that can be used directly as marine bunker fuel or as input for refineries to produce biofuels. The second element is the recovery of water, considering that more than 7% of organic waste is water. We can really recycle a huge amount of the waste that is put into the plant. We can also produce a small amount of biomethane. The technology is a very, very low emission technology because we have just very small production of CO2 that can be also captured, purified, and commercialized. Another characteristic is the reduced soil usage compared with the traditional technology of biogas and composting. And finally, considering that we are interested to apply this technology in the United sites around Italy that are in several cases sites that need to be requalified, it is also an opportunity to promote the reuse of industrial sites, avoiding the virgin soil consumption and promoting job opportunities. This is the last slide, and I will thank you for your attention.
Thank you very much, Marco, for this nice presentation and really very interesting ideas on how to go further. So certainly there will be some questions at the question and answer session. I will give the micro back to Laura.
Yes, thank you, Pietro. We are going to the next speaker, who is Petra Scanferla from Fondazione Università Ca' Foscari. She will present the paper, the work, the validation of converting pyrite ashes contaminated soil into end of waste by Hbss application, I suppose, high performance separation, that I can ask her. She is a field researcher responsible of the Center for Sustainability at the Fondazione Università Ca' Foscari in Venezia. Please, Petra, the floor is yours.
Thank you very much. My speech concerns an application developed by companies such as MAPEI Group, that is an international well-known leader on construction additives, and TAV Group, which I have thanks, that represent a successful case. I can say also a unique case of inertization of waste, a contaminated soil by heavy metals, where it was allowed its reuse as an end of waste in agreement with the principle of the circular economy. Let me introduce very quickly the context in which we supported the validation of this technology. I work for the Ca' Foscari Foundation, the instrumental body of the Venetian University, which promote the technology transfer activity. In particular, I manage a project of the Center for Sustainability, the C4S, the Center for the Validation, and the technological support for sustainability, which aim to transfer skills in the field of sustainability to the local area and businesses. We developed a validation study for innovative technology, especially in the context of the circular economy for contaminated sites, but we also developed a model for the assessment of the sustainability of remediation sector. I'm talking about framework with the LCA approach and so on, that my colleagues already presented at the last year here at the Remtech Europe, that we developed with Any Rewind. So thanks to Any Rewind. Why do MAPEI, TEV, and the local environmental agency, the ARPA, needed our support? Because the stabilization solidification technique are not well regarded. The heavy metals, which all of us knows that are not possible to degrade, represent even now a big issue. A big issue due to the difficulty to accept by the authorities and the citizens the use of a stabilized matrix which still contain the contaminant. It's a big issue, and now the remediation approach is often the dig and dump or the confinement that are not a sustainable solution at all. In this case of inertization, a third-party endorsement, in addition to the usual checks carried out by the control bodies, had helped the end of waste approval, and thus the possibility to reuse the remediated soil in situ and to certify the remediation as well. But much more than this, the authorities certificated that the treated material is an end of waste that can be used also for other applications, such as inert in the concrete formation. And as some of you already knows, the Hbss, that means high performance stabilization solidification, is already a consolidated technology applied since the 2006 in more than 15 contaminated sites. And I already presented at Remtech Europe in 2013 the evaluation of the sustainability of this technology. The technique is particularly sustainable as it allows the use of the stabilized soil and greatly limit the disposal. So is more environmental sustainable. It is cheaper than other solutions and more acceptable from a social point of view. But the new Italian law regarding the end of waste had raised some doubts in the possibility of declaring the material as an end of waste, especially in the case in question where the ground was heavily contaminated by heavy metal and by pyrites ashes. The performance control was therefore particularly important, as I'll present to you very soon. The Hbss has over time proved to be a technology that gives guarantee of durability and high performance. The cement-based technology transforms the fine soil fraction into a high-density, low-porous, and mechanically resistant granular material that can be reused for backfilling and looks like a synthetic gravel. It is based a technology that is based on high-performance concrete, the science that study additives and mixing design, able to realize concrete that allow with very big construction and durable building, for example, the tallest skyscrapers in the world or the biggest Chinese dam. In relation to this formula that make in relation porosity with the water and cement ratio, the Walton formula, more you manage the decrease of the water cement ration, thus putting less water in the mix, the porosity will be lower. So the capillary permeability can be significantly modified through the water cement ration, and the capillary permeability determines the durability and the mechanical resistance of the cement-based material, and also its water permeability, which is virtually zero for a water cement ratio of 0.32. Thanks to specific water cement specific additives called MAPE+ Eco1, it is possible to reduce the water cement ration and obtaining obtaining high performance inert soil. In addition, the heavy metals are not only physically stabilized, but also chemically stabilized, mean their precipitation is much less variable species, therefore in a metal hydroxide in relation at high level of the pH given by the cement. Those two images show the difference in the matrix with or without the additive, and the relative water and cement ratio that can be obtained using the additive that go from 0.71 without the additives to 0.40 with the additives. Here you can see a classic flow chart of the Hbss application that works with a fine fraction. So you need to saving the material and and use the fine fraction that is the fraction that is contaminated. And here you can see the most important phase that are also very simple phase, that is the mixing first and the granular phase after. The mixing design is generally provided for 70% of soil fine fraction, 25% of Portland cement, and 2% of additives, and the rest of 3% more or less of water. And then there is the granulation phase, which due the so-called avalanche effect produces spherical and granular materials, those whose dimension can be decided and varied with a certain range from a few millimeters to few centimeters. Now let's move on the case study, which is particular significant case. It was in fact an abandoned industrial area where there was a chemical fertilizer factory with ovens for the production of the sulfuric acid in lead chambers obtaining from a roasting of pyrite, whose ashes were scattered in the southeast area of the plant. The industrial activity of determined a soil contamination by heavy metals, in particular arsenic, lead, copper, cadmium, and zinc, and cobalt. And here in this table, the table shows the maximum concentration value of the main pollutants found during the characterization plan. So as you can see, we had very high concentration level of arsenic, of copper and lead that are higher, the higher concentration, but also the mean concentration are very high. And here you can see the bright red pyrite ashes. Think that for the level of iron and the level of lead, in some point the soil had a density of more than 2 tons per cubic meter. The excavation operation had produced 39 lots of about 400 cubic meter each. And similarly, the monitoring plan provided for check on 39 lots of granulate produced with a very strict and continuous control. The perform verification protocol include Los Angeles crushing test that measure the abrasion of the material, the leaching test, ecotoxicological test, and also the monitoring of the groundwater after the refilling. The Foscari perform a lot of sampling, and ARPA analyze the 85% of the sample for the leaching, and then 100% of all the samples for the toxicological test. Some results: the Los Angeles test for the verification of the mechanical properties are under the limit of acceptability, so we need less than 45% of crushing in order to have a material that can use for the road foundation. So this material can also reuse for the road foundation. Then here you can see the results of the verification protocol of the leaching test, and that the protocol provide for analysis for 8 polluting elements presented in the soil. Zinc, cobalt, vanadium, and cadmium have always resulted below the detection limits, while only 3 elements showing this in this graphic show quantity above the detection limit in the leaching test. We are talking about arsenic, copper, and lead. In any case, all the result was below the limit for the waste recycling. Then the ecotoxicological test we carry out every 3,000 cubic meter of material, and was performed directly by the environmental local agency, the ARPA, and where liquid phase bioluminescence inhibition test with vibrovisceri, an algae grow inhibition test, and the immobilization test with Daphnia. So, concluding, after the refilling with the granulate material, the environmental agency performed another sampling. This is a particular, using a statistical approach of the standard 1510, found out the number of increments necessary to have a representative sample of all the total material inside after the treated soil. So they sampled 56 increments to obtain a final sample at 2 depths, 1 and 2 meters. And the test conducted, here you can see how the soil are at the finish of the remediation, and this is some photos about the ARPA sampling, about these 56 increments. And the test conducted on this final sample confirmed that all the mass can be qualified as an end waste with a confidence of 99% and desired precision in sample. So final remarks: circular economy requires new technologies, and the rising of the skill also and above of the members of the local service conferences who approve and certificate the project in order to take the right risk, and not to be scared about a new technology, a new application. We have the last remarks regarding the leaching test required. That is, as in Italy, we perform for the waste, is the EN 212 457, the part 2, that are not suitable because the stabilized granular material need to be smaller than 4 millimeters as a size, in order to avoid the size reduction by crushing. Then, as you can imagine, powder crushing affects the performance of the leaching, of course. So we suggested to perform the part 4 of this test the next time. That means can you use the material, the granular material, as is it, because you can perform this one stage batch test to soil of 10 of a size of 10 millimeters. So this is our suggestion. I need to say thank you for your attention, and yeah.
Okay, thank you, Petra, for your nice presentation. Now I'm going to give the floor again to Juliana for the next presentation. Thank you.
Thank you. I would like to invite to speak about the construction and demolition waste management policies for improved resource efficiency, the Conderef project. Credo che sarà Antonella Luciano, giusto? Da Enea che parlerà.
No, should be Elisa, which has to name as co-host for presenting a presentation.
Okay, so Elisa.
Maybe.
Hello.
Okay, are you there? I didn't see you.
I'm not really sure.
Sorry.
No, it's just fine. Let me take this. I think it will be maybe easier. But I'm not sure if I will be the only one presenting, or Alexandro is also going to intervene.
So please.
But in any case, I start. And
please.
If you want to. Share. So this is.
Okay, perfect.
Can you see the screen?
Yes, perfect. Thank you.
So I'm here to introduce Conderef. Conderef is an Inter-Europe project funded by the European Union. And its main aim is tackling the policies regarding to the construction and demolition waste management policies for improved resource efficiency. My name is Elisa Peñalvo, and I will be the one speaking about the project, since we as Polytechnic University of Valencia are coordinating these specific activities or this specific project. In the project, obviously other entities are participating, such as Enea and other regions that I will name later on. So what's the context of this project and how it was born? How is it possible that there was some interest in Europe, and how the idea came out? So one of the things that is very easy to understand is that construction and demolition waste is one of the heaviest and bulkiest waste streams in Europe. And here we have a chart where we can see what are the differences in the construction, demolition, and all the other waste generated in Europe. So it's a huge percentage of the overall. So we realized that there's a high potential for recycling and reuse, and they could become a really high value for the market. We identified during the research for the proposal that there's a market for the reuse of this construction and demolition waste that aggregates in roads, drainage, and other type of construction. And the technology was already there, was already ready and accessible at a reasonable cost. So these were the main motivations in order to propose and carry out Conderef. So what was the next step that we identified for Conderef? Well, during the process of studying the background and the context of this construction and demolition waste management, we realized that there were many different approaches on how to tackle the issue from the different EU regions. And we were missing cross-country comparison and especially cross-country collaboration. There were many best practices in other countries that could be implemented in other ones and vice versa. But there was still several countries that needed a push in confidence. They needed to understand that really the quality of those recycled materials were good enough and had the enough quality to be implemented as a added value product. And this is where all the different regions, or the idea from all the different regions across Europe, on the participating regions, are putting together. We are improving the policies at the local level in order to enhance and promote this kind of quality, really, construction and demolition products. So we are not talking now anymore about waste. We are talking about added value products that can provide a lot to the market and that will receive within the market. What were the objectives? The objectives that we planned within the project were to support the integration of the EU construction and demolition waste management protocol into the different European territories. We were thinking also to strengthen the capacity of the public authorities by developing a series of methodologies and a series of events and trying to gather and collect the information and the perception of the public, but also the main stakeholders. What were their needs, what they felt that was needed in order to really leverage this implementation, etc. And many of the activities that we have carried out respond to this, meeting and interviewing different stakeholders in order to make sure that we understand what's the need and if it was the same in the different regions and how we can approach it from different perspectives of different European countries perspective. So let's say, for example, we have identified many lessons learned in different, for example, in Austria, that it was well received in Italy, or in Italy that it was very interesting for Spain and vice versa. So it was a really putting together in a common ground all the different lessons, but also the best practices and the ideas that we had at the European level. With all this, we identified, we are putting together in our own public authorities, trying to improve our practices in the management, generation, tracking, and processing of these products, and trying to bring it also into the level of the policy in order to integrate it with the actual CED policies. How are we doing this? Of course, we're trying to push and share with all the different stakeholders and public in general and our public authorities the benefits, the economic benefits associated to the reusing of these materials. With all this, our idea is to change that initial perception of lower quality and increase the confidence of the different regional stakeholder actors in terms of reducing the value chains and the CED-wide management. Here are the different regions that we are participating in this really specific project about construction and demolition management. We are a Polytechnic University of Valencia in Spain. We are collaborating with the Valencian region in this regard, trying to help them to prepare the new policies associated to this. But we also count in the consortium with the region of Thessaly, the Environmental Energy Agency in France, another agency in Czech Republic. Of course, ENEA, that is one of the main research actors within the project. The Lazio region, representing an Italian region, the Styrian government in Austria, and finally from Germany, a research institute that is ISW. So what are the activities that we have carried out during the project? Has a duration of 5 years. Right now we're in the third, so many of the activities now have been implemented, and in the second phase of the project, the idea is to implement the different outcomes of the project and try to push the recognition and the change in the policy in order to make sure that we have an impact on the policy instrument. So initially, we developed several methodologies and analysis and studies in order to better understand what's the context of these kind of products. We developed a learning policy with the different stakeholders, being continuously in contact with all the actors, understanding their needs at all the different regional levels, and understanding what are the aims within what they consider there will be a feasible, but also a convenient and environmental friendly objective. With all this, we have developed a series of cross-regional learning where we had the chance to learn from each other's experiences, and we have developed as well a capacity building. So in terms of training, to train all the different authorities regarding all the lessons and best practices identified in the project. With all this, we developed a tool, and we have developed several methodologies and how to improve and how we can track all these waste or added valued waste that will become in products. And now the next step will be to have an impact on the actual policy instruments in order to make sure that this is a generalized approach in all the different regions. Additionally to that, the project also includes communication and dissemination with many different activities associated also for the general public and for the stakeholders, so that it is approaches from different perspectives in order to make sure that this impact is as wide as possible. And finally, the project management. So what kind of methodology we have implemented? Initially, we developed a comparative regulatory framework in the management and assessment of these products that was carried out in the leader, but it was not. It was a European comparative analysis, not just Spain, but it was led by Spain. So us, in our case, then we developed an economic potential C&D waste and predicted areas that was developed by Germany. We have analyzed the capacity of the different territories for recycling. And finally, ITA, in this case, and make a wonderful job in mapping the public, the stakeholders and public awareness, perception, and acceptance of the potential and value waste, construction and demolition waste reuse. So here we have different meetings where, as I mentioned, we share with different actors at the different regions what will be the next approaches, what we need in order to impact the policy, and what should be included in those new policies in order to make sure that we go to the next step and we make this, we enhance the impact of this leveraging a new normative and new directives. Here we have an example of the cross-regional learning and capacity builders. That was before the pandemic, where we had the chance to have presential workshops and presential meetings. Since then, we had different partners that had presented the work, but mainly, unfortunately, it was mainly online. Regarding the policy improvement tools and resources, as I mentioned, we have identified many different, approximately around 20 best practices around the different stakeholders within the project and all across all the different participant countries. We have shared and uploaded into the website to make them available for everyone, but also to make sure that our regions have the chance to check them out. And we have identified also cost and benefits best practice. So from all the different practices, then we have approached and we made the analysis in order from a cost benefit or economic perspective. As I mentioned, we also developed a tool where we can track and trace what will be the waste generated in a construction and demolition site. And this is going to be implemented in 2 pilots in the next 2 years within Spain. So far, this is from my side. These are the websites, and if you decide to follow up, we still have 2 years to go. So we still have an action plan to follow and to implement all the different actions that we mentioned in the previous slides. So I remind for your questions if you have any, and I just want to say thanks to the organization and ENEA for inviting us in this forum to give and provide visibility to CONDEREF that I think is very necessary nowadays. Thank you.
Thank you, Elisa. Very nice. And now I pass to Peter to invite the next.
Thank you very much,
paper.
Juliana.
Thank you.
I think we are at the last presentation of this part, and probably Francesco Tinti, who will be presenting the recovery of critical raw materials from stockpiles and tailings. There was already some advert made by Paola Altamura before. So here are the details of the project. Francesco, the floor is yours.
Thank you very much. I'm sharing my screen. I hope
it's on the screen.
Can be seen. Is
Yes,
everything
it's
okay?
full screen. Yes.
Full screen, perfect. Thank you very much for the invitation to this workshop. This is Francesco Tinti from University of Bologna. I belong to the Georesource and Geoengineering group of engineering department of University of Bologna, and we share the legacy of the old mining school of the engineering of Bologna, which, as you may know, it was suspended in the 80s. This project is a project financed by EIT Raw Material, and in our mind it was a mining project, in fact, in the new era, in the circular economy era. And it comprises many partners, among which ENEA, thanks to Paola and Laura, Dr. Cutaia, and many others, some of them from exploration, some others from excavation, and finally some from processing, the classical stages of mining. This project is named the International Consortium to Recover Critical Raw Material from Stockpile Tailings targeting Greece. And here you can see all the contact person of all the organization. I will cite briefly them. Dr. Bodenan from Bergem, Bureau Recherche Géologique Minière from France. Laura Cutaia from ENEA. Ekaterini Pagle from Mytilineos, an aluminium company, an active aluminium company in Greece. Professor Dimitrios Panias from National Technical University of Athens, processing group of mining school. Joachim Schick, Dr. Joachim Schick from Orano, a French company working in uranium management, and among the various activity, the uranium recovery and uranium extraction. Professor Buxton from University of Delft, working in exploration, it's a mining engineer. Professor Guido Sonnemann from University of Bordeaux, from the life cycle group, and Professor Alexandre Chagnes from University of Lorraine Mining School, Processing School. As is the title, the idea was to create a consortium to study this problem. And this problem is to recover critical raw materials from stockpiles and tailings, from both a recovery issue, the mineral issue, and meanwhile environmental improvement, because in some areas these tailings are still there, and they cause an environmental hazard. This risk in the title is a regional innovation scheme in practice in IT raw materials policy. There are some areas with more attention. Among those, Italy is one of them, and Greece and Balkans others. And so in practice targeting Italy and Greece, more or less. These are the administrative details of our project. I will not focus too much on that. You can read here sustainable discovery and supply and securing raw material supply. The project started on 1st January 2020. It's going to end next December. So it's going to end, but our aim is to keep the consortium, which proved to be very effective. Our targets is, since it was quite an innovative project and a hot topic, an innovative project, we started with reviews from sampling, characterization and processing techniques in 2020. Then we made a data collection of stockpiles present in Italy and Greece, in general in Italy and Balkans. As and Med countries, also some of them from Spain and some of them from Cyprus, for example, but the focus mainly was Italy and Greece. And among them, we selected one, which was the methylenous tailings in Greece of aluminium, bauxite tailings. On these, we made some detailed analysis. And we want now, in the last months, according to the time remained, provide some pre-feasibility studies for economic and sustainable recovery. A very important aspect of this project was to create links between us, and because of that we organized roundtables with experts, and also inviting resource-rich emerging countries, emerging economies, REM, inviting, for example, technicians from Brazil, from mining countries, Iran, and so on. Most of them online, but we managed also to do some hybrid. So for expectation, we wanted to fill the gaps to gaining a list of full-scale technique which can be applied really to recover these critical raw materials, these materials from tailings, to try to open the path to new opportunities for valorization of these areas which are now affected by mining waste, to promote circular economy mining, some sort of green mining, demonstrates the potential of recovery coherent with EU environmental standards, and promote, as I said, the international cooperation, also to arrive to some products. This is the final target, but I think it will be a target for the future. Here the consortium, I already presented them, and we were quite at the 3 vertex of the triangle of knowledge, 5 higher education, 2 business, 2 research, Orano and Mytilinio's business, Enea and Bergem research, and the others universities. This was the time frame of our project, in which the first year was dedicated to these reviews that we made, and everything can be seen in the website, our results. While the second year is dedicated to the practical activity on this selected tailing site. We organized 2 roundtables. The first one in December 2020 about the challenges, and the second one lasted 2 weeks ago in September about opportunities. And and I will explain later. Along all the path, the work of Enea with market scenarios, environmental issues related to green mining, and with, of course, special focus on pilot site. And as all projects, management and communication. I will briefly describe the general main activities, and then I will focus on the work package regarding environmental and market issues. Work package 1 was organization, so we had to manage this in COVID era, and was not so easy. Then we organized these 2 roundtables with experts, the first in Bologna, both in hybrid mode. So some people managed to come to Bologna in December 2020, but overall in Athens, joined with the ROMAT 2021 conference, which was a very big conference with more than 2,000 participants in presence and other online, about the topic of raw material and circular economy. And there we discussed the issues with a wide audience. Over 60 mining experts, we provided useful suggestions and insight for the technical parts, which were basically work package 3, work package 4, and work package 5. Regarding work package 3 as technical achievements, we realized 3 comprehensive reviews. As I anticipated before, we realized a small because there are not so many information, but database of mining residuals in the area. And among those, we selected 8 potential case studies, which had some interest for recovery of raw materials. And among these 8 selection of 8, we selected one that was the bauxite tailings in Greece, on which we performed sampling strategies using also satellite images to create a grid based on sampling strategies and material flow analysis. And over that, we performed a big grid of samples, where now these samples are under examination from the labs of Orano, Bergem, and Technical University of Delft. For future steps, according to the analysis, we should characterize critical raw materials in this tailing and provide some pre-feasibility studies for future projects. Now I'm focusing on the work package 5, that I think is also the most interesting for you, where partners involved were mainly Enea as work package leader, together with Bergem, which has a life cycle group, University of Bordeaux, and the companies which are providing the main data. Orano regarding the management of nuclear tailings, and Mytilinio's because it's the owner of pilot site. Work package 5 provides an overview of the possible economic and environmental interactions of stockpiles tailings recovery process with the market of primary materials, in order to highlight economic and environmental strengths and weaknesses of the circular approach in the mining sector, with the goal to demonstrate that this recovery is feasible, but both in economic and environmental terms, and to prove that this exploitation of critical raw materials in Europe and from mining areas of Europe can represent an opportunity for sustainable economic development. As you can see here, circular economy is declined in not a very circular way, because there is the insertion of raw materials with the extraction phase. And we are working on, from one side, insertion of raw materials, studying the tailings, and from the other side, trying to prove circularity from residual waste from all parts of the circle overall in the mining sites. Now the research methodology was divided in 3 parts. The definition of methodological approach, with what is written here in form of a decisional tree considering the context of mining, which is something new. This circular economy applied to this topic. Contemporary, there is the need to assess and the supply and demand of market dynamics, with the analysis of the value chains of the critical raw materials that are potentially recoverable from this site, the site we are studying, but in general, the abandoned mining areas, and assessment of environmental impacts in a life cycle perspective with material flow analysis and, for now, a simplified LCA study. Expected results are the example of procedure, pre-procedure for combined environmental and economic assessment. Because at the end, to really extract material from waste means to touch those waste. And to touch those waste should have an economic advantage for the company doing it, and an environmental security for the regional authorities, because static waste can be non-hazardous, but when it's touched again, can become hazardous. And these are the targets. The methodology adopted is a funnel methodology for economic assessment, starting from the critical raw material list, going down to a recoverable critical raw material supplying from stockpiles and tailings, then going deeper to the recoverable critical raw material in general in bauxite residues, because of the geology and the processing of this residue, and finally to find profitable critical raw materials in the metylineous, in our case study, in the specific bauxite of metylineous. Here we can see an example of value chain description for gallium, which is one of the targets that the consortium has individuated. Here in green, there are all the possible, the probable, because now the analysis are ongoing, critical raw material present in the bauxite residue of metylineous. And in green, they are highlighted the ones which we would like to focus. Scandium is very much studied together with bauxite and aluminium for some processing reason, but we want to focus also on other with very low concentration and grade, but with potential. And here, for example, for gallium, some data and analysis on how it is used and the value of gallium in time. So relevant impact categories and indicators have been selected for this tailings management. Material flow analysis was done, and these environmental impacts, thinking of a recovery, have been highlighted and described. Try to, for one side, to quantifying the impacts avoided by recovery, for example, gallium from the case study, instead of extracting from a mine in China, for example. And on the other side, understanding if after tailings reprocessing, the residues might present environmental criticalities, among which we discussed toughly in the roundtable the radioactive content of these tailings after reprocessing. Another thing I want to highlight is that the legislation now treats these mining residues as waste, and this is based on the Directive 2006, and this directive provides many information how to treat this waste, but considering them as waste. The idea would be to push public opinion in general not to consider them as waste, but as secondary resource, exactly as for the urban mining. These are some benefits in critical raw material recovery from this secondary source, which we want to call them secondary source, not waste, mining waste. And this was a general paper in which they have evidenced in qualitative terms all the benefits of doing this activity. Finally, I conclude with work package 6, communication and dissemination. We have a website which I invite all of you to visit if you are interested in more information on this project and the achievements. And here you can read our strategy for communication and dissemination, and we are in line with the 80 raw materials, because at the end it is 80 raw materials financing the project and moving the project according to European standard. Thank you very much, and then let me thank the organizer, Enea, for inviting us and telling me to present also their part. I hope have presented in a good way, and all the partners of the consortium. Thank you.
Thank you very much, Francesco. Very interesting presentations with some examples. I'll give back the micro to Laura to conduct maybe the question and answer session.
Yes, thank you, Piotr. I'm going to maybe to read if there is some question in the chat. Just to mention. Yes, probably the first question is from Bogdan Scaleanu. I'm sorry for my pronunciation. I thought I don't know on which presentation he will mention, because he was asking what investment is necessary and which is the return rate of investment. I guess it was the first presentation on any. But I asked Bogdan to confirm if his question was related to the any presentation. Maybe he can write it on the chat, and I give the floor to Annie to answer.
At least I had the impression that it was when Marco presented, so probably this is the right.
Yes,
Yeah.
maybe the question is for me. Okay.
Okay.
Thank you for the question. Regarding the internal rate of return, is very complicated to give an unique answer, because it depends on the tariff that you pay to treat the waste, the organic waste. Just to give you some additional information about the economic model. The economic model of this kind of project is based on two main main revenues. The first one is the income from the tariff that the municipality will pay to treat the organic waste. Then there is another revenue that comes from the selling products, that in this case mainly on the bio-oil product that you can sell. But if you can, if I can give you some order of magnitude, I can tell you that the tariff is an incidence of around 80% on the overall revenues. So because the situation I was speaking about Italy is very different between municipality, especially if we pass from the south to the north of Italy. The internal rate of return can be really different in each situation. For example, there are situations in the north of Italy where the economics are really low, while if you pass in the south of Italy where the tariff is higher, the economics can be more interesting. It depends also on the composition of the organic waste. Also, the composition of organic waste is different in each situation, because it depends on the habits of people in consuming. So it's difficult to provide to you an overall question. There is another additional element related to Italy based on incentives, because there are some incentives to produce biofuels. Those incentives at the moment are related to industrial plants that are put in operation up to 2022, but it's expected that those incentives will be also in the future interesting. For example, for what concerns the anaerobic digestion for biogas, the incentives are one of the most important element in the economic model. So I'm sorry if I cannot provide to you a simple answer, but it is because the situation is really complicated.
Marco, sorry, there are some two more questions for you.
Okay.
I ask you to maybe to answer a little bit quickly, because there are other questions for other speakers. The first question is about, I'm going to read you. Did you realize a life cycle analysis in the perspective of your 2024 plant treatment capacity? For the waste to fuel process from the pretreatment to the final product, is there any carbon input that will be released from the transformation? Thank you. This is the first question. The second question is about what percentage is the solid residue from the organic waste in the waste to fuel process, and what is its fate? What percentage is the solid residue from the organic waste in the waste to food process, and what is its fate?
Okay, I'll try to answer quickly. Okay, regarding the LCA, yes, we performed an life cycle analysis for this technology, and especially for the industrial plant. The results were very interesting, because the bio-oil produced compared to other biofuels that are listed in the red two tables is one of the most interesting in terms of CO2 produced per tons of waste processed. Regarding the second question, the amount of solid residue is in a range of 5 to 10%. Also, in this case, it depends on the composition of the organic waste in the input, because, for example, in area where you have in excess of bones, seeds, and so on, all these parts cannot be transformed through an hydrothermal liquefaction. So you will find it in the final residue. Because the final residue maintains also a portion of bio-oil, it will have an interesting eating value. So you can burn it and you can obtain the heat useful to sustain the reaction.
Okay. Thank you, Marco. There are any other questions from the public? If not, I have some general remarks. Also taking the opportunity to read.
Laura, sorry, Laura.
Yeah?
May I ask a question? Is ever for Marco, if possible?
Yes.
If there are no other questions for the other speakers, I would take the opportunity. I am not an expert, Marco, of those kind of plants. Consider my question a simple citizen. No, I would like. I see those plants for 100 tons, no, per year. Very, very important. And my question is, how many capitals or big cities in Europe have similar plants? Are diffused, or let's say it is still a technology that is still to be applied fully?
Okay, you consider that currently we made a choice on the size of 150,000 tons per year based on some assessment based on the best revenue on capex that we can expect. So maybe in the future we could be able also to design smaller plants. Regarding this kind of size, it can be applied in a context where you have a number of person in a range between 1 to 1.5 million. So it could be a good solution for all the big towns. For example, in Italy, you can find at least 10 to 15 towns where you could apply this kind of solution in proximity. There are, in general, in Italy, you can find every kind of sites. For example, there are also 2 or 3 plants that can process more than 500,000 tons per year. So 3 times the solution that we are now proposing.
Could be useful also for Rome, that has a lot of problems.
Yes,
for this.
yes, for Rome, for all the main towns in the south of Italy, for example.
Okay, Laura, floor to you. I think there is another question from Marco. For Marco from the chat. I apologize with the other speakers because Marco is collecting all the questions.
No, I have a question for Petra, and I cannot make question for. I apologize, but I cannot make question for speakers where my name is mentioned in the same work. But I have a question for Petra. The question is about the process and about the situation you managed. Did you have, or maybe your financer had any problems from the point of view of from the legal point of view?
Not because the project was already approved the end of waste and the waste of the material. So after the validation and the approbation of the project, we performed the project as was approved. So at the end, we have no problem. The remediation has been already certified. So the local authority that certified that the remediation already done it. So the remediation is concluded.
Okay, thank you. There is another question to Marco.
Yes, I read the question in the
Yeah.
chat regarding the purity of bio-oil. The answer is no, because the hydrothermal liquefaction is a selective process. As mentioned during the presentation, mainly the fatty substances and proteins will be transformed through this process. So at the end, in case of presence of not organic components, you will find it in the solid residue, not in the bio-oil. The bio-oil maintains a quite constant composition.
Okay, thank you, Marco. Can I maybe just mention some general remarks, just some thoughts on this session? I think that given the comment of, I don't know if you have read you have seen the comment of probably a student or something like this. I don't Mihedi Hang Azan Soag. I don't know the pronunciation is, if it's correct. I don't know, probably not. Is about a guy. Oh, I don't know if a guy was a girl. I don't know. I'm sorry. But the point is that these issues are really interesting. And I guess that in this moment, for me, there are issues really interesting in general. But in this moment, these issues are really interesting and really important because of the Next Generation EU, the Green Deal, and all the huge amount of funding and the huge amount of things that have been done in the next year in terms of huge amount of materials, huge amount of energy to be used to move towards the circular economy, towards the transition to the ecology. But in the meantime, we have to use a huge amount of materials. So we have at the same time a huge amount of material, the needs of huge amount of materials. We have some huge problems with regards, for example, of old landfill sites or old tailing sites, old mine not more used in Europe. We are moving towards the new regulation for the circular economy. All these things together has to be used as an opportunity to use better our resources and also to use better the secondary materials. In the presentation of Francesco Tinti, but also in the presentation of Petra, we have, but also in the presentation, the first presentation of I don't remember, Suzanne, probably yes. We have the problem of the old materials abandoned. Now we have to combine the need of recovery the sites, but also in the meantime to use the materials that are in there to do new materials, to do new things, to answer to the needs of the Next Generation EU and also of the Green Deal. I think that it's really important in order to avoid to buy and to excavate more materials from primary sources. This is my simply thought. I ask other chairs if they have some other consideration general. Thank you.
I wanted also to thank all the presenters because we have seen different points of view and also different focuses. So one of which, for example, is the segregation of waste, if we are talking about landfills mining. So I think that different, let's say, steps of product life is very important, and we have seen it from the very beginning until the end. There is also this strong link I would like to repeat with the policy session as presented at the beginning of the REMTech, where we have learned or have heard about life cycle assessment and the European Commission work on this. And so I think this is becoming a crucial subject in different processes, in Green Deal, in Next Generation, in Bauhaus, and I think that all these initiatives are very important for people, for citizens, and also, of course, for the remediation and technology business, and that is helping at and should collaborate to solve the problems. So it was really a pleasure to listen to the presentations, and I hope that tomorrow is going also to be a nice day. So thank you very much to all the speakers and co-chairs for running this session.
Piotr,